Hi, everybody. Welcome to Robot Builders Night Virtual for Dallas Programmable Robotics Group for April 8th. And tonight we have, Paul asked me to mention to everybody that Trish was looking for volunteers to help out with the VEX Robotics. I can find his message. She's looking, asking for help for interview teams on April 23rd. Paul said he's able to volunteer, and he wanted to know if possibly anyone else would be looking to help out. So if you're interested in helping out Trish on the 23rd, get a hold of Paul, and he can fill you in on the details. Aside from that, we have a few presenters tonight, and I guess we'll start with Ted.
All right. Yeah. So this may or may not be just a quick question for the group, but I am building an outdoor robot, and I added GPS to it. And the GPS unit takes an antenna with an SMA connector. And I had basically two choices that I found online, one with a 6-inch antenna cable and one with a 6-foot antenna cable. And the 6-inch wasn't long enough, so I went with the 6-foot. So I'd like to shorten it so I don't have this huge length of antenna cabled up. I thought of a couple options for this. One, to take out an X-Acto knife and cut it and then splice the ends together. And I thought that might not be the best way to deal with an antenna signal. And I see Tom shaking his head no. So my other thought was to get a little SMA connector and meant for that type of cable and crimp it. And I was wondering if any of you had experience doing that and how hard it is to crimp on a connector.
You mentioned SMA size. Those are very tiny, right?
Yeah. Let's see. I have it here. It's the kind that look like a
little cap.
They look like the old TV antenna.
It's smaller. So that's why it's like, ouch.
Kind of like that?
Yep.
Yeah, that's probably the same kind. And the cable, the cable is like 2.5 millimeters in diameter. And I have found on Amazon for $30 a set of connectors and a crimper meant for that type of cable. So I'm thinking I might just try it and see. But
Yeah, had a look at AliExpress.
Yeah, that's probably another place I should look.
Yeah, like Tom and I both have had really good luck. You pick some of their choice products.
Okay.
And they arrive in a week and a half.
Okay. Now, who knows now with the tariff situation here, but
that's going to be
he's in a different situation.
Yeah.
Ted, what the actual wire that goes into the antenna, is it an epoxy puck? It's the
right.
Antenna.
Let's see if I've got. Oh yeah, I got an antenna here. So this is the other end, and it's just kind of solidly glued together.
Yeah, but they're pretty cheap, right? They're not.
Right. Yeah, I think it was about $15. I just couldn't find one with anything between 6 inches and 10 feet of cable.
Yeah. Well, so what I did was I opened that up.
Oh, okay.
Okay, and then shortened the length. Saw where it was soldered to, and just shortened the cord and soldered it back on, and it worked fine.
Oh, okay. Yeah, well, and I have another one that looks like this, but it's got a really short cable, but I could, I suppose, take one of the other cables and try it with this first.
Mm.
I think I already had, this is an old one. I don't know how old, but there's hot glue on it and it's all dented up.
Yeah, yeah. What I'm just saying is, let's see here. Give me a second.
Yeah, like this one though, I might try opening it up just to see what it looks like on the inside there.
This is what it looked like after I took it out.
Oh, okay. Okay,
Okay.
yeah, so that kind of looks like this guy here.
Yeah, it's got. What's not so obvious is there's like a metal can underneath. This is the antenna on top,
Okay, yeah.
and then there's like a circuit board, and then underneath there's like a metal protection, a shield.
Okay.
So you do have to, I believe you have to remove that shield temporarily. It's just soldered on.
Oh, okay.
And then unsolder it back on when you're finished.
Hmm.
It worked.
Ted,
I had the same problem with the 6-foot antenna.
Yeah.
what was the problem with the 6-footer, Ted?
Oh, it's just that I have like all this cable just
Okay. So it's just a question of where to put it.
yeah, exactly.
All right. You have an opportunity for an interesting experiment here. You could do a signal strength test before you cut the cable and do another one after you've put it back together again, simply by taking a look at how many satellites you can get under the identical monitoring conditions. That
Yeah.
might be worth sharing to see how good this approach is.
Yeah, cool.
I like Doug's suggestion. That makes more sense than cutting the cable, I think.
Yeah.
Well, I
Yeah.
did cut the cable. I custom measured how far I wanted, and there was no degradation in signal. I mean, the number of satellites. I mean, if you have one of the new ones, if you have a GNSS, you'll pick up a lot of satellites. But anyway, that was how I approached it, and I did put a little 6-inch ground plane underneath it, and it seemed to help a little bit. And is it absolutely necessary? I don't.
This is my
know.
idea here.
Yeah, something like that. That's what I did. So I wanted to get rid of the magnet in there. That was another goal of my project. Otherwise, the one I had a magnet so it was meant to be like stuck on the top of a car. So when I pried the case off, I got rid of the magnet, and I just got rid of that. And I did all of that partially because I was going to have a compass in the near, around. It wasn't going to be right there, but it was going to be around. And I didn't want the magnetic field interfering. So it was kind of like a win-win, I got my cable, the custom length, and I also got rid of the magnet.
Yeah.
One other thought that you might consider too is if you're concerned, I wasn't too concerned, but if you're really concerned, you can 3D print a case to fit on the top of it.
Yeah.
To give it a little more weather resistance. Yeah.
Now this particular one I have, the magnet was just glued on the bottom. So
Yeah. So you just knocked it off.
Yeah, I just pried it off, and that was fine.
I think I didn't bother to pry it off because I was getting rid of the little plate that was underneath it.
Yeah.
Yeah. But the same effect.
Yeah. So Doug, was the center wire just soldered to 1/10 pin spacing, and then the shield wire soldered to another one?
You're asking me a question of something I opened up 2 years ago. What I would say is, it seemed to me that the shield, which was attached to the ground, and I believe it was attached to the shield also. So you just gotta, when you're taking it apart, you just gotta notice where the wires go. I don't think the soldering was a big deal. Okay. And I did do one thing. when I put it up on, so I mounted the actual unit on some little standoffs that went onto just small standoffs that went to my plate. And I made sure that where the standoffs were, that they were soldered so that I had a good ground on the shield.
Right, but I don't think you'd actually need an electrical ground. It's
No, yeah. So I'm just saying is, I'm just telling you what I did.
Okay.
And that, you know, like I say, it worked, that wasn't a problem.
Okay.
I would think you would need an electrical shield, or electrical ground. It's otherwise, what is that very tiny signal reference to?
Actually, what you'll need the ground for is you're feeding power into that device as well to drive the low noise amplifier that's right next to it. So you do have to have both wires.
Yeah.
Oh, okay.
Yeah, but I want to say yes. But
Is it like a
Because they are-
I wanted to make sure my ground plate was grounded. All right. So now, is that absolutely necessary? I'm not sure, but that's the way I did it because I've seen too many projects go weird because somebody didn't have a ground on it, you know?
Yeah. But the signal, the plate for the signal ground, I don't think that has to be connected to your electrical ground.
Yeah, might not.
But because I've never
Yeah, it
done
could be
that.
separate. That could be separate. Yeah.
You know, I've always just like mounted these antennas to steel plate without doing any electrical connection. So
Right, exactly. That's, so that I'm just saying what I did,
okay.
I
Yeah.
just
And it worked.
and it worked. So, would it have worked if I didn't do that? Probably,
Yeah.
So, but anyway, but you definitely need to, like Tom said, there's the shield and there's the center wire, and both of them have to be connected. You can't let one of them just float.
Right.
Makes sense.
I'm just kind of peeking in the end of one that I have sitting here. And yes, the wires are just soldered to two different points on the printed circuit board that's inside there.
Yeah.
They're very short. They're very close to each other, which you want, but that's all that. You don't want to melt them together when you solder them.
No.
Yeah.
All right.
Yeah, you just follow whatever they did, chances
Yeah.
are you're good.
It's a good suggestion, Doug.
Yeah.
Yeah, really good.
Yeah, you don't think they're doing microstrip or strip line design for RF signals on the little printed circuit board, do you? No, it's just okay.
They're a
I don't
little
think
crude.
so.
Little crude, yeah.
I took one apart. All right, I looked at some papers for some people who took some apart, and there's not a whole lot to them.
Mm-hmm.
All the serious design work is done in the micro patch itself. So that's where all of the fancy RF reflection and non-reflection stuff happens.
Yeah.
Once they get it onto the circuit board, it's going through the low noise amplifier, and the low noise amplifier is feeding the coax cable. 1.5 gigahertz. It's not that big a deal.
Okay.
You will get reflections in that cable though if you're not careful. That's why attempting to slice the cable with an X-Acto knife and splice the cable ends back together is probably not a really good idea, because it would be really hard to avoid impedance mismatch.
Yeah, that's what I figured.
Yeah.
You'd have a voltage standing wave, I guess, maybe.
You start to get echoes, reflections within the cable pieces, and that's going to distort your signal. That's not a good thing.
Right. Or mismatch impedances, yeah.
Is there any other questions, Ted?
That's all I had. Next.
Okay. Next, we had John.
Okay, let me click on something. Okay. So I saw this the other day, so I'll click on this one. So seemingly we're having somewhere around in uptown Dallas a robot that can deliver. So I don't know if I am somewhere out there. Click there. So yeah, the Uber Eats one. So I don't know if you have that anywhere else, but seemingly we have one. Unfortunately, I don't live in that uptown Dallas, so I don't know how good it does, but
I wonder if we could temporarily kidnap one, like put a tinfoil hat over it so it can't navigate or see, and then.
Yeah, I had a friend in Addison. I think it was Addison. He saw one on the street, so they're around.
Yeah,
I got a truck.
I've never seen one personally close by, but I don't know if they really show the pitch. Yeah, they're very. Oh, there it is. Okay, so yeah, basically it's like a nice chest box with a nice little flag.
Yep. And a whole bunch of Samantha. Yeah, Samantha. That's what it's supposed to be called.
Yeah, it looks like it has a little window in the front to talk to people and that. So
a dark bag over the top. No.
yes, you could probably kidnap it relatively easy.
A robot napping?
Robot napping, yeah. There you go.
Little Faraday bag.
What makes you just take your food out of it and not somebody else's food?
I think it only delivered to one person, then goes back and get refilled. But
There must be some kind of barcode or something on your phone where you can just scan it, maybe. Or I don't know. Just guessing.
And how is it going to squish the pizza so that the cheese is all stuck to the top of the box like the delivery guy does?
so yeah, so
Just put a pizza in that's too big for the cooler, or just shove it in there.
There was that. And I don't know what will happen once I click. So let's see. Okay, I may have to reshare for the other tab, it looks like. So yeah.
Yeah, I was trying to figure out if that thing actually had it actually looks like it has DC motors on the wheels. I thought maybe it had brushless motors on it. I was thinking, wow, that's but they look like they're just DC geared.
And then okay, I can't just click. Okay, so you have to go there. Okay. And the other thing was, hopefully this will work. Yeah. So then the other thing I found was this article in Instructables. And it's a ROS-based robot, so talks about the battery and stuff. Oh yeah, and the arm, where it's sort of a gripper arm for the ball. So I don't know if that's better or worse, but seemingly he thought he likes that. Here's where he talks about using ROS. A little bit. And then seemingly using something called Move It, whatever that is. And then after at the bottom, I found this. So FYI, they're seemingly having a little contest on that closes on May the 12th. So for it, if you all want to submit something, you can to it. And right now, this is basically what they have in it. So
yeah, what happens is as the end gets closer, the more people will jump in. But the one you showed,
The first one,
Yeah, that one.
the Dallas one.
Looks like it would be with some modifications, would be a good candidate for the SRS Get Me a Beer contest.
Oh, this one, this
Yeah.
useful robot home.
Yeah.
Well, it does seemingly, it seemingly has.
It looks like it has
water
everything.
bottle.
I don't think you'd have to figure out how to open the fridge. But other than that,
Yeah.
it looks like it. And I'm not particularly crazy about that wheel system, but anyway.
The only reason I can see why using the real system he did is that it doesn't have to go to turn. It can literally go, straight, left, right, wherever.
Mm-hmm. But it also means he has to do it on hardwood or something like that.
Well, the ground has to be relatively flat.
Yeah. Well, that'd be cool.
So there was that. And then if somebody, I'll just click and get, So are you seeing my screen right now, or do I need to click?
All we're seeing is the 5 entries.
Okay, so I do need to close and reshare then. Okay, so there's this one article that actually is pretty good. I found 2. Okay, present. Let me. Okay, so present. And then, okay, should be a thing called Okay, so and then here's this 2 real one. And his video looks like whatever software / program he's using is pretty good. It goes into about the principle, the process. He talks about the 3 parts of PID. So if you're into that looks like pretty good.
Slide up a little bit. I saw it talking about the DMP. So this must be, what do they call it? The one that's 2050 or whatever for the IMU. Did that slide down?
Okay, I haven't looked into it a lot, but
He uses the 6050.
okay.
Yeah, the 6050. Yeah. Okay.
There it is. It just went by.
Yeah.
Next paragraph up, I think.
It's shown in that schematic too.
Oh, there's the chip. Okay, yeah. Yeah.
6050.
So the article, it looks good. It has well documented type things, especially for the PID with the code and that. So there's that, and I'll get to the video. But at least on this video, it looked like and he uses the cheap motors to boot. So
Wonder if that uses the same code that Harold was talking about. There's somebody did it a long time ago.
right. Well, I haven't tried this one, but the article flash demo looks pretty decent. So it's like, well,
You can sure see the limitations of those motors, though.
I know. Well,
I think it's just trying to hold still.
Yeah.
you can see when he pushes it a little bit, it can do better.
This project is sponsored by PCBWay. They have all the services you need to create your project at the best price, whether it's a...
So anyway, So yeah, so if you're into the wanted to
But one of the things you notice on this, or at least it looks, this is all it can do is try to balance. You know, it's not like Dave's robot where he can actually drive where he wants to go.
right. This is just sort of getting the basic foot in the water stuff. And I thought it was, for that pretty good article. So that's why I brought it up mainly.
This project is sponsored by PCBWay.
Yeah. So yeah, and as I say, the fact that he has a pretty good description about the principle and the code there, and I thought was pretty good.
Yep. The real trick would be to build one and see if it
really does what advertised.
Yeah.
And the video looks convincing, so yeah. And right now, I guess those motors are relatively cheap. So yes.
Well, before we leave, John, I want to ask what people think about the first thing he brought up, which was the robots, that were the little icebox robots that are
nice robot downtown.
Yeah. What is the business model for that?
Good question.
I mean,
don't pay the Uber Eats driver. Just give the robot. I think it tries to take the driver out of the equation, and
but it would only be very local. I mean, I'm not going to have one from downtown Dallas drive up to my place, which
that's a last mile. It's a last mile.
It's
type
the last
of robot.
mile.
They started. I think their first trial in the Dallas area was up in at UTV.
Yeah,
lots of those running around, and it's really a last mile kind of proposal. It's not meant for like roads.
Well,
but I mean, I could see something like UTD where it's a business campus. I mean, think of it as a campus, and they, maybe there's delivering mail from department to department or something from department to department, but just general neighborhoods. You're going to have to drive up to it someplace with a big panel truck and carry them all out.
Multiple of them. Instead of having one Uber driver, you have literally plenty of these buses laying around type thing. So, it's like every foot there's effectively a box there.
But they have to be really expensive to maintain and keep running. So I don't see how it's less expensive than paying a driver, $16 an hour.
Well, for a while, I don't know if you all have that up there, but for a while they had these rent a bike type electric bikes downtown that, and they were literally every street corner. There was one laying there. So if you really wanted to be lazy, you could get on.
But that doesn't work, John. That's got a lot of problems. First of all,
I agree.
They also, and I remember the pictures of the creeks they showed in Dallas that were filled with those bicycles that people had just hauled them over the bridge.
Well, yeah.
And then the second thing is
they are left everywhere.
Yeah, that's not the last mile model. The last mile model that I would think is they would drive up to, let's say he was an Amazon driver. They would drive up to the edge of the neighborhood. He'd open his panel truck and 20 robots would roll out and go the last mile. And then when they got on your porch, they'd poop out a package and then go back. Somebody, it seems to me like though that's like you said, somebody said that, it'd be easier for just to hire a guy for an hour and let him go deliver them. So
how does it ring the doorbell?
Well, it probably sends an email.
Right.
Oh.
Your phone.
It probably takes a picture and sends an email saying your package has been delivered.
Notifies your app.
Yeah.
Ours don't.
Yeah.
We get an email and that's it.
Could be a jobs for federal workers, that got laid off.
Yeah.
So the food delivery robots were tried in Toronto back in 2020 and 2021. They ran into several problems. First of all, it was basically a standalone company that was providing a service to anybody who wanted stuff delivered in a short range. The first problem they ran into was objections and some accidents with both regular bicyclists and pedestrians. So that created a problem for the robot company. Within a year, the city council in Toronto had banned them all from the entire city.
Yeah.
So legally, they weren't allowed to operate them anymore. That was the end of that experiment.
That's what happened here with the scooters. They were such a hazard being thrown in the street and everywhere that they banned them.
I think the same thing happened in, I think it was Vancouver, that people would jump on them. You set up an account, you jump on them, and the idea is you can drop them off wherever you want.
Yep.
So these things would be abandoned in the middle of nowhere, and now somebody has to go by with a truck or whatever to pick them up and bring them back to a charging station and get them charged.
Yep.
The
And so
bicycles and the scooter things were fueled by like hype financing. It was all speculative financing. They assumed it was going to be next big .com type of thing. It never had a really strong business model behind it. And you could argue that, well, I guess the robots have to sort of prove themselves as well, but they're only going to be applicable in really high density environments where they can get, they can cross maybe max one street, but they require sidewalks to get by and stuff like that, at least the kind that we've been looking at here. And they're not meant for long distances. They're meant to dwell within a neighborhood. So like at UTD, I was seeing students who were like ordering from a fairly nearby pizza place, but they didn't want to bother to go out and go get it. So they'd have it delivered by the robot. But I think there's a lot of novelty purchase as well. Like people just want to see what the heck it's going to do. So I don't know what the long-term business model for it is. But the good thing is you don't have to tip.
What about drones?
It's the same thing with drones, yeah. And I think they actually
they're
have
more dangerous.
They're more dangerous, but they're more flexible as well. But
I can see, the first time somebody gets a jar of tomato paste dropped on them accidentally from the drone,
I like the concept, Doug. I think you made about you have 20 of them come popping out of the van. So you drop some in the neighborhood and then pop out of the van and then form the neighborhood and then they go back to the van.
I think there was a horror movie about that, wasn't there?
It'll be like Halloween then. Instead of children popping out of the car, it'll be robots.
I thought I saw another one starting up in Dallas, Fort Worth by the airport. A flying drone looked like a great big cooler, fair size, and to deliver parts, stuff, whatever, not food. And I think they were testing in the Dallas area for now.
I'm thinking I remember something, but it was like about 2 months back. And you're right, it was more over in Fort Worth than Dallas.
Yeah, one I saw, it had like a quadcopter and it had a cooler hanging underneath and it would lower it down on a cable and then poop out the package and haul it back up.
Yeah.
I just saw it and threw it away.
Yeah. It'd be really, like I say, I guess there might be some special cases, especially if it was something that was like that you would do every day. So actually, like something like mail delivery, if we all had special mailboxes, custom-made mailboxes to fit with the robot, where the robot would just go down somebody would load the robot at the beginning of the day and it would just go down the route. But, it would have to be pretty good size because...
What could go wrong with replacing a postal worker with a robot?
Yeah. I don't know. What if your robot goes postal? Anyway, I don't know. I'm just
I
trying to
was
think of
postal.
something where it would work.
In other words, that you don't want it too small and you don't want
Yeah.
it too big. And finding that sweet spot, I think, is going to be the key.
I could see it, somebody parks in front of a mailbox and the thing spends all day trying to get into the mailbox, but can't get there because there's a car in the way,
You have 10
Anyway.
seconds to comply.
Yep. So if their head moves first, no, what is it? If the body moves first and then the head, he's scared.
You're muted, Tom.
You're muted, Tom.
It would make it a lot easier to automate mail theft, though, right?
Yeah.
We'll just hack the program that's running the mail delivery robot.
Yeah. Anyway.
Yeah, I was going to
Who's
say,
next?
I don't know if it was true or not, but there was a rumor that some postal worker was taking just the cash contributions that were sent to Reverend Tilton. I don't know if you remember Reverend Tilton. Anyway, it was like $600 some odd $1,000 that they figure he got just with the cash contributions alone. So,
Well, John, were you done, or is there more?
Yeah, those were the articles I saw that I thought might be of interest. So, yeah.
Well, thanks, John. That was
Yeah.
quite interesting. Next up, we had Tom.
Okay, you guys have probably all heard about the iFixit website, the website that takes stuff apart and shows you what's inside. I got a link in one of my engineering email streams today pointing out that they've just done a disassembly on probably the most expensive, sophisticated toy they've ever bought, which was a robotic dog. I'm going to share you the little intro video. Where's the share button? Here it is. See if I can find it. There. I'll just show you a minute or so of this because it's half an hour long in total. You can see that.
Just seems wrong taking that apart.
Must be a pointer.
I was disappointed in that. I saw it and they didn't finish the teardown. They stopped before they started taking the legs properly apart.
Yes.
And that was the most interesting thing. That was the one I was waiting for. Most of it's about just, the body and getting access to the heart, the compute module inside, that kind of stuff. So I found it actually quite disappointing. Should have kept going.
There's your beer server. They go bring a beer to you.
It's
So
a
how
pretty
much
long
does this
video,
robot
though.
cost? It's like, wow, it can do a lot better than I thought it could do now.
Well,
So do we know how much this thing costs to buy?
It's about $2,000.
Huh.
So
I'm
when I Googled it,
impressed
I saw the price points all over the place, but
Right.
it seems to be a nice
Yeah,
medium.
it's improved drastically the last couple of years.
Tomorrow it'll be 4,000.
Well, true.
There'll be 10 more purchasers.
Yeah.
What I thought was interesting in the teardown, which I agree did not go nearly far enough, they did disassemble much of the structure of the LiDAR, which is in the nose. And it's the most sophisticated, interesting looking LiDAR I've seen. It has two motors and has essentially several degrees of freedom in terms of what it can scan.
It's a 3D LiDAR.
It looks like it, yeah. It's worth watching the latter part of the teardown just to see the details of that LiDAR unit.
Didn't look like it did too well on those stairs. I don't know if you guys saw that.
No, it's not very good at climbing them, and it tends to jump to get back down.
And the problem with it probably is the spacing of the steps aren't wide enough for it to really work with. I suspect it's very geared for a certain type of step.
So
I think it's more the algorithm isn't as
Well,
developed as what.
Yeah, but I mean, if you have a 20-inch between your two legs, you know, and the step is like 18 inches, somewhere in there, you're going to eventually have a spot where you're right on the edge of the next step. That's why I say that it's probably geared for a certain width.
now they point out that the device is not autonomous. It does have internal GNSS and Wi-Fi along with the LiDAR. They didn't mention any other sensors. And they didn't point out what the GNSS was used for. So whether they have plans to expand it, or this is, I think, the entry-level robot, and they have at least one more that's more expensive, considered to be the Pro unit. So they may, if you're willing to spend more money, they may have versions with a bit more autonomy built into them. Anyway, that was it.
Oh, interesting.
$2,000 is not bad for a reasonably functioning four-legged robot.
Next up, we had David. You're
Muted, David.
You're still muted.
There we go.
Yeah.
Okay. A couple of weeks ago, Paul showed a Ross robot, a very simple one that used a Waveshare general driver for robots board, and it got me interested in starting to work on robots again.
Okay.
Dirty.
Cool.
Excellent.
That's it.
Well, that's great, Dave.
Are you going to enter it in the contest?
Yeah, you're going to be ready?
I hope to be ready for the quick trip.
Okay, cool.
Awesome.
Hey, it's got some of the characteristics of a standard David Ackley robot. I saw the handle.
Oh, yes.
Yeah.
That's based on David Anderson's criteria. You should always have a handle, and you should never have it go faster than you can run.
Yeah. Yeah. Cool.
So that's it.
Okay.
Hopefully I'll show you more later.
Yeah.
Well, thanks, David. Next up, we have no one. So I guess if anyone has something to present, they can go ahead.
Mike wanted adding.
Oh,
Mike?
yeah, go ahead, Mike.
Hi. Yeah. Well, a couple things. One is I was telling you about the rotator that spins art on the wall. Well, I gave it to the artist, and he mounted his art to it and put it on the wall. And then he left and came back, and it was on the floor. his painting was on the floor.
Yeah, okay.
So I have to have a better mechanical attachment. So right here is the mechanism. There's the motor here. It's a geared motor with an angle to it, and thanks. And there's a shaft on the motor here. It has and you can't see it very well, but it has a flat spot. So I designed something that went on there. It was ABS or PLA, and with a set screw that I threaded into it, and it looked pretty good. But it was a little flimsy. It was like the piece of artwork sort of hung down a little bit and pulled itself off. So I'm gonna add a bearing to hold the art to the body of this, and take out all those forces on the shaft of the motor, except for just the rotational force. So I tried to cut a corner and it didn't work.
Yeah.
So that
Well, that's
motor
cool.
doesn't have bearings in it already, or?
It's a nice big bearing. It's a yeah.
Yeah.
I had some 8mm interior diameter, but they were well. I have to put some screws in there in the insert on the print to hold the whole thing together properly, and it didn't have enough room around the shaft to put screws into it. So I had to get an 18mm internal dimension bearing. So it should work fine.
Yeah.
But
That'll
your
be
motor
interesting
didn't
to see.
have a bearing in it already on the output shaft?
Oh yeah, it did, but but the attachment to this output shaft, I couldn't get a good attachment to it, and
Oh, okay, yeah.
it ended up just being a little
Just
weak
falling off, yeah.
in this direction, and then it slid off. It had some force to pull it off like that, because the artwork sticks out there and it's pretty heavy, so it has some
Yeah.
angular force to it.
Yeah, it's like a cantilevered load or something.
Yeah, so I'm gonna redo it and take all the forces off that shaft except for it rotating, and all the forces will go onto the body here, because he said this thing wasn't pulling away from the wall; it was flat, but the art was pulling away from this thing. So
yeah.
Oh well, it worked good with my art I had put on it, but not his. His was much bigger, so that's on that. And then last week I was talking about my Ross stuff, and so I've been working on that, and it's much slower than I really wanted. So I'm going to, oh, there it is. Share. So I added some sensors on it. You can't see them very well on here. So this is the six can course, and I put some cans on there. You can probably, I think you should be able to see them, sort of shadows down there. And in RViz, you can see the cans, but that's not what this particular. And basically, I'm just using my laser, not my laser sensors, but my what are those called? The solid state ones that I have. And so it sees the cans using the solid state laser, or TOF, time of flight laser, or sensors. But I had some problems in the fact that the Ross navigator seems to want to back up a lot, and it didn't have any visibility. So I added some sensors to the back, and that was what I've been working on. And so you can sort of see, I'm going to manually drive it, just using the keyboard. So you can see the front sensor saw the can, and I'm manually driving instead of letting Ross do it. But I'm gonna stop this and let Ross drive it. So I'm gonna put a goal to say go to this can. So my front field of, you can see the yellow squares over here. That's the eyeball on the left side, and then the pink or the orange squares scattered around. See if I can make this bigger. Hold on. Yeah. And then the orange squares here are the right eyeball. And then I have two sensors on the back, or three sensors on the back. And you can see that this is noticing the wall right here, and then this one here is noticing the can right there. So if I just do a little rotation here, yeah, you can see my back sensor is sensing. And then this is the green is the front sensor. It's not an obstacle sensor. It's what a pull-in sensor for the object, for the can. So I put some sensors on there. So that's pretty cool. But then I was going, okay, I need to feed these range sensors into the navigator. And so I went into the file to add it to it, and it said, oh, we don't accept range sensors. We only accept scan or point cloud sensors. So now I got to convert the range sensor into a point scan message topic, and then so then I was working on it, trying to do it in Python, and it's like, what the hell? I can publish range sensors, but I can't subscribe to a range sensor. It just refused to do it. Just gave me error messages. So now I'm doing it in a C, and at least I got it to compile. And so now I can convert these range sensors into a laser scan sensor. Like this one here, I would put like maybe 5 points on the laser scan scattered around this area here, and so it'll know that there's something here and it's an object that it wants to avoid. Like, it doesn't know exactly where it is, but it knows it's somewhere in here. So I need more than 1 point in the middle. So I just need, like, I'm thinking of 1 point every 10 degrees, just to give it something to see without having a lot of data. But putting 1 in the center just wouldn't be enough, because the object might be really over here. So I'm still working on the ROS, trying to simulate it, and I looked into stuff, and like, I think I know how to put a servo on here with a claw, but I haven't got to that point. I wanted to get the sensors working first. So we'll see if it turns into a live robot, but at least I'll have something relatively complicated that matches my real robot in simulation, so I can test out the different algorithms, the different navigation algorithms. So that's what I'm doing.
Well, thanks, Mike.
Yeah,
Good update. Nice progress.
How to stop? Oh, there it is. Okay.
So does anyone else have something to share? Thought I saw Fernando on there. Usually you have something, Fernando? Nothing today, I guess. Doug, do you got something? I guess not. Well, looks like it might be a short meeting tonight, guys.
Yeah.
Well, I got something I wanted to talk about a little bit, Pat.
Okay, go ahead.
Okay. All right. So if you're like me, you probably get a lot of little crap from China for robotics. And there's an article put out by NPR, which is National Public Radio here, and it's titled, "Trump Closes Loophole Used by American Shoppers to Buy Chinese Goods Tariff-Free." And so I'm going to read just a paragraph from that, because it's got some stuff that's kind of interesting that I wasn't quite aware. I knew that this was coming. So it says, so long as each individual package is worth $800 or less, they aren't required to pay import fees or go through typical custom inspections. But under an executive order signed by Trump Wednesday, that loophole will be closed on May 2nd. And now this is the part that I really kind of got into. These lower value shipments will now face a tariff of 30% of the value of the postal item containing goods for merchandise. Well, okay, so that wouldn't be a big deal if you're buying a $2 package. All right. But the next sentence says, with a minimum fee that will eventually raise to $50. So it could be, I don't know what, it doesn't say timing of that condition, but you know, if that were to come, that's going to just kill, you know, buying a little ESP32, you know, because you'll have to get it from a place like Amazon, which is going to be buying a chunk of them and storing them in the United States and then selling them individually. But anyway,
Yeah. And
something to know.
even then they'll be 30% more expensive. Or
Yeah, they're
50%.
30% more expensive, but like I say, most of the prices are so low, and I suspect that the Chinese vendors will probably absorb some of it. But I also read another article saying that I think with a deal with, you know, trying to de-escalate all of this stuff, China is saying that they're going to reduce the number of small packages that will be shipped to the United States. So otherwise, they might be. I don't know what you know. When you're talking about the Chinese government, you have no idea what a statement like that means. So I mean, it could mean that if your thing doesn't have a $50 value, you don't ship. You know what I mean?
Well,
I don't know.
My guess, Doug, is they'll ship it to Vietnam and then ship it here, or ship it to Mexico and then sell it to here.
Yeah, or even store it here in the United States. You know, like I say, you could ship it direct, ship it and store it. If you were in big enough quantities, it probably wouldn't be. I mean, yeah, you still have a big chunk, but it's not a $50 minimum value thing. But like I say, it didn't say when that was going to occur. But apparently that they're going to have two evaluations of it. One is whatever the postage says it should cost. And I'm sure you've all gotten a package that said something like sample or something, and it basically no value, or $2 value or something like that. And then, but the other one was apparently there's also going to be a minimum fee, which will eventually escalate. So we'll see. I just thought, since that impacts us pretty strongly for parts.
My guess is to get around it, they'll ship it someplace that has a no tariff deal with the U.S. and then they'll sell it here from there. So it'll be the same stuff. We'll just be getting it from like Vietnam or Mexico or someplace.
Yeah.
And,
they can't send it to the Penguin Islands because they got a 80% tax on that.
Yeah.
so
Anyway,
anyway,
I had one show up at the door.
So they'll
I
go
had
to
one
the
show up
Penguin
at the
Islands. Yeah. Anyway, just I saw that when I saw that minimum fee, I just like, that was new. I had not heard of that.
Yeah.
And so that was kind of a shock.
Doug, you mentioned a 30% tariff from China to the U.S. Is that tariff not going to over 100% starting tonight?
Okay, things are so much in flux, Tom. Anybody who writes an article today could be wrong tomorrow. But I don't know if it's talking about $800 and less, which went from 0 to 30 maybe. Okay. I'm not sure, Tom. I don't know. Maybe you're right. I did hear that they were going to go to 100%, but well, we'll see how that goes. I mean, I'm just, because you can say whether it's good or bad. At this point in our hobby robotics supply line, there's nobody in the United States. I mean, there are some very good companies like Pololu who make stuff, but I'm sure they make their stuff from China. Do you know what I'm trying to say? So I don't know exactly what's going to happen. And we have Adafruit, and we have. But I also thought, well, what about JLC PCB? What's going to happen there? They have a $2 special. I suspect that probably will not change. But what'll happen is that you'll be charged more than $2.
Like
but
50.
it'll, huh?
$50. Yeah.
Well, if it goes to that, that could happen, and this could set us back to the days when we were making toner. What do they call it?
Toner transfer PCBs.
Yeah, right, Tom. We could be back there again.
Good thing I didn't throw out my etchant bottle yet.
Huh?
Good thing I didn't throw away my bottle of etchant yet.
Yeah. So
did you hear the other thing that China is doing in retaliation?
No,
so there's a bunch of rare earth metals and products, and China has basically issued an order that no more deliveries or refining to the USA.
Yeah,
and there's some of these places, 90% of the world's stuff is refined in China. Those minerals.
Yeah, so that means
yeah.
Yeah,
so
that probably
it sort of puts a kibosh to globalization. We've all done globalization since the early 1900s.
Yeah.
Parts get made for vehicles everywhere, and we buy chips out of everywhere.
Yeah. But I would imagine what you just talked about will kill what do they call neodymium?
Oh, that's just part of it.
Yeah, but I mean that's going to be gone for sure. So
yeah. There's all sorts of rare metals that they use for these chips and stuff like that are basically going to disappear off the market for shortly.
Yeah, well, I'm not too worried about it because I think in the short term it might be a mess, but in a year or two they'll figure out how to ship it to some other country that ships it here. So it'll get here. It'll just have to go a circuitous route. Everything will cost a little bit more, but it'll work itself out. So I wouldn't be too worried about the world falling apart. But yeah, it's going to be a pain until then.
Yeah, I agree with you, Ted. I don't worry about it falling apart. I'm just trying to figure out.
Yeah.
Like for example, I'm actually gearing up to teach a class down here, and I would have to source robot parts for 10 robots, and this could be a major impact on that. So
yeah, in the next few months, it's going to be a mess, I'm sure.
Yeah. So anyway. But so if you wanted to get any of those AliExpress orders going, I don't know if you could even order them now, whether or not they get caught or not.
Amazon.
Yeah, back to Amazon.
Yeah, because you could order it now, but who knows if you'll actually get it or not.
Yeah, that's true. Yeah.
Well, I forgot to share my reverse backward sensors.
Okay.
That sounds cool.
So let me allow. Screen. I clicked on stuff. There it is. Yeah, so this is a Pololu sensor, and so they have some like this is sort of a nice little thing they have.
Mm-hmm.
Can you see this?
Yes.
Great. Yeah, so they got a set of sensors, and the chip on this board can control 3 different sensors. And so they put these transmitter LEDs here, and these 2 here is for this one segment of 50 degrees, and then these 2 are for this segment of 60 degrees, and these 2 are for this segment of 50. And so the like the bottom of the board has the receive diodes here and here, and you can see the top of the board has these here. So they go out and then they reflect back and go under the board. So it looks like it has a very narrow vertical range because of the shadowing of the circuit board and stuff.
Mhm.
They didn't talk about the vertical field of view, they just talked about the horizontal field of view. So I assume it's just basically a flat line across that.
Mhm.
So it uses the a chip called the OPT 3101, which has a I2C on it. So I'm hoping I can just put on my I2C bus that I have some other sensors on and get it to work. So I bought it a couple of years ago, and finally says, "Hey, I need it now." So
Yeah,
I'm gonna pull it out, dust it off, and use it.
What is it? What does it have for range? It's pretty short, isn't it? About 6 inches or so.
1 meter.
It's like a meter.
Oh, a meter. Okay, that's
It's
good.
really gone up in price as well. If I remember,
I
it
know,
was
it's really expensive. I'm glad I got it when it's cheaper, but
Yeah.
so where is it? Where does it say?
$46 US each.
Yeah,
I know.
at the top, they were $56.
I would not have paid that much, so it must have gone up.
Yeah.
I think I paid $30 Canadian for one
Right, something
Yeah.
like that. Yeah.
when they first came out, and unfortunately, I ruined it. I scratched it, and I broke a trace, and
Oh, no.
I haven't been able to get it to work.
Mhm.
I was looking on here trying to see that particular range spec. So I guess I'll find out when I get it. I thought I read in here somewhere like a meter or a half a meter, but at least a
Okay.
meter.
Well,
Right there, specifications.
Oh, where does it say it?
30.5 millimeters. Oh, that's dimensions. Sorry.
Oh, dimension. Yeah. But I just don't see the range. Oh, it says 1 meter. Okay.
Yeah, up to a meter. Yeah.
Yeah, I thought it was 1 meter.
Yeah.
Depending on our target. Cans are hard to see, so I would say it could probably work to half a meter on a can. So
yeah.
some reliability.
Well, this could help you from backing into a wall.
Right. Well, backing into a wall or backing into a can or something, but yeah. But a wall would be easy to see. So you can see where it's mounted on their robot. So I'm gonna do something similar.
Yeah.
So well, that's
What
my
is that? What does that say? What robot base is that? That's a Pololu robot base.
oh, I don't know.
What does it say?
Where, does it say something somewhere?
It says on
Yeah.
a
TI
RSLK Max.
RSLK.
huh. I
Max.
Where's that?
recognize that. I don't recognize that.
On the subtitle below the picture.
Yeah.
Oh, okay.
Looks like the Romy.
Yeah.
Yeah, I thought that was made in junction with TI.
Okay. That
Or-
might be. That
Yeah.
could be. TI did make a few of those. Made a few of those micromotor robots. Yeah.
Let's see. Where's,
Okay.
Yeah,
where's our search?
That's a TI robot thing. I'll paste the link I got.
Oh, okay. So here's a whole bunch of stuff. So
Looks like a Romy.
It would be
That
really,
says Romy, yeah, right there. Yeah.
well,
I just checked the price on the Zumo that I bought from Pololu. It's already gone up $50.
Oh,
Yeah, it's now $195.
I'm gonna stop presenting. All right.
Yeah, because the prices keep going up.
yeah, that's the thing with Pololu that I've noticed is that they seem to be under a lot of pressure on prices. They've gone up and up and up. I mean, they make great motors, but I want to say they're like $50 a pop now.
Wow.
Yeah. Now, if you buy it during Black Friday or something like that, that's what I do. I wait until they have their big sale once a year, and I stock up on things that I need. So,
Yeah,
anyway.
I stocked up on their Christmas sale, and a couple years ago, I bought extra motors and stuff. So
Yeah.
but I have high hopes for that backup sensor.
Yeah.
Yeah, can't wait to power it up.
Thanks, Mike. Does anyone else have something to present tonight or questions?
Okay.
Okay, guys. I guess we will stop the recording and say good night.
Okay.
Good night.
Good meeting. See you guys.